Okay, we're going to go ahead and start the last section of this unit, and I'm going to spread this section out over this entire week. So in today's video, we're probably going to get about halfway through the lesson, and then we'll save the other half for in class on Wednesday. So this lesson is going to deal with radicals, exponents, nth roots, and rational exponents. So first thing we're going to get into is our laws of exponents. So there are a handful of these that we're going to look at. We're going to let A, B, S, and T be real numbers where A is greater than 0 and B is greater than 0. So law number 1 says if we take A raised to the S power and multiply it by A raised to the T power, so we're multiplying two exponents that share the same base, we can combine that into a single exponent by adding the powers. So that's going to be equal to A raised to the S plus T power. All right, law number 2 says if we have A to the S power, which we're raising to the T power, so if we have a power raised to a power, in this particular case, we are going to multiply the exponent. So that's going to be equivalent to A raised to the S times T power. Okay, if we have A raised to the S power divided by A raised to the T power, so if we're dividing two exponents that share the same base, that's going to be equal to A raised to the power of S minus T. All right, law number 4 says if we have A times B, and we're raising that quantity to the S power, so if we have a product raised to a power, I can think of distributing the exponent across each of the factors. So that's going to be A raised to the S power times B raised to the S power. Same thing if we have a quotient raised to the S power. If I apply the exponent to both the numerator and denominator, that's going to be equivalent to A raised to the S power divided by B raised to the S power. Okay, law number 6. If we have A raised to the negative S power, there are two ways for me to write this. I can either write it as 1 over A raised to the S power, or the other way I can think of this is I can take, because the exponent is negative, I can take the reciprocal of my base, so the reciprocal of A is 1 over A, and then raise that result to the S power, which is still 1 over A raised to the S power. All right, law number 7 says if we take A and raise it to the 0 power, that's going to be equal to 1. And lastly, law number 8 says if we have A raised to the S over T power, so if we have a rational exponent, the denominator of the exponent becomes the index of our radical. So that's going to be the tth root, and the numerator is the power. So we can think of that as the tth root of A raised to the S power. Another way for me to write that is the tth root of A, and then we raise that entire quantity to the S power. Okay, so for example, if I have 2 to the 1/2 power, if I want to rewrite that in the form of a radical, the denominator 2 is the index of our radical. Well, if we have a square root, we don't write the index, okay, of 2, and then we're raising 2 to the first power. So 2 to the 1/2 power is equivalent to the square root of 2 to the first power, which is the square root of 2. Okay, next thing I want to talk about are perfect squares and perfect cubes, because we're going to use these to help us simplify radical expressions. Okay, so if I want numbers that are perfect squares, I want to take each of the positive integer values and square them. Okay, so the first perfect square is 1 squared, which is 1. The next one is 2 squared, which is 4. Next one is 3 squared, which is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64, 9 squared is 81, 10 squared is 100. I'll do a few more. So 11 squared is 121, 12 squared 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, and that's more than enough. Okay, and then perfect cubes. So if I want to find perfect cubes, I want to take those integer values and cube them and see what values we get as a result. So when I take 1 and cube it, 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and that's good enough for us there. We don't need to go much bigger than that. Okay, so with that said, we're going to get into our first set of examples. So the directions ask us to simplify the expression, and then we are to assume that all variables are positive. Okay, so for number 1, when we have the square root of 72, anytime I'm simplifying a square root, I want to try to break that quantity up into factors that are perfect squares and factors that are not perfect squares. Okay, so the largest perfect square factor of 72 is 36. So I'm going to break rad 72 up into the square root of 36 times the square root of 2. And then the square root of 36, we know that 36 is a perfect square, so rad 36 is going to be 6. And then we're left over with the square root of 2. Okay, so that's what the square root of 72 simplifies to. Okay, for number 2, when we do the cube root of 54, so I want to break, because we're taking a cube root, I want to break this radical up into factors that are perfect cubes and factors that are not. Okay, so the largest perfect cube factor of 54 is 27. So we're going to break that up into the cube root of 27. And then my leftover factor is going to be the cube root of 2. So if I want to simplify this, the cube root of 27, 3 cubed is 27, so the cube root of 27 is 3. And then we're left with the cube root of 2. Okay, if we want to simplify number 3, the fourth root of 16x to the 12th power times y to the 7th power. Because we have a fourth root, we want to break this up into the fourth root of like values that are not perfect squares, not perfect cubes, but perfect things raised to the 4th power. Okay, well, when we look at the number 16, 16 is 2 to the 4th power, because 2 to the 1st power is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th power is 16. Okay, so that's going to be a perfect value raised to the 4th power. X to the 12th power, so that exponent 12 is also a multiple of 4. So that's going to go underneath the first radical as well. And when we have y to the 7th power, I'm going to break y to the 7th power up into y to the 4th power, because that's something raised to an exponent with a multiple of 4. And then the leftover factor we have is the fourth root of y cubed. Okay, so if we want to go through and simplify this, the fourth root of 16 is 2. The fourth root of x to the 12th power, again, like I can take that radical and write it as a rational exponent. So that's going to be x to the 12 over 4 power. And then we have y to the 4 over 4 power. And then we're left over with the fourth root of y cubed. Okay, so that gives me 2. X to the 12 over 4 power is x cubed. Y to the 4 over 4 power is y. And that leaves me with the fourth root of y cubed. Okay, so that right there is that expression simplified completely. All right, let's look at 4. So with number 4, we have 3 rad 6 times 2 rad 2. Okay, and we're multiplying those two things together. Okay, so if I'm going to multiply those two expressions together, I'm going to multiply the factors that are not underneath a radical. So we have 3 times 2 gives us 6. And then I can take the two factors that are underneath the radical. So when I multiply rad 6 times rad 2, I can take that and combine it under a single radical. So that's going to become the square root of 6 times 2, which is the square root of 12. But we're not done yet. We want to simplify that expression. So I can take the square root of 12. I want to break it up into factors that are perfect squares and factors that are not. So the largest perfect square factor of 12 is 4. Our leftover factor is going to be 3. So we get 6 times the square root of 4, which is 2, times the square root of 3. And 6 times 2 is 12 rad 3. All right, and that right there is that product simplified completely. All right, for 5, we have the square root of negative the square root of 18 plus 2 rad 8. Okay, and I want to go through and simplify this. So we have negative. I want to break the square root of 18 up into factors that are perfect squares and factors that are not. So the largest perfect square factor of 18 is 9. And then our leftover factor is 2. Plus 2 times, if I want to simplify rad 8, again, I want to break that up into factors that are perfect squares and factors that are not. Okay, so the largest perfect square factor of 8 is 4, which leaves us with a leftover factor of 2. Okay, so let's go through and simplify this. So we have negative, the square root of 9 is 3, times rad 2, plus 2 times rad 4. Rad 4 is 2, so we have 2 times 2, which is 4 rad 2. And then negative 3 rad 2 plus 4 rad 2 is going to wind up becoming rad 2. And the reason that that becomes rad 2 is if I factor a rad 2 out, that leaves me with negative 3 plus 4. And negative 3 plus 4, that quantity there winds up becoming 1. So 1 rad 2 is rad 2. All right, let's simplify the expression in number 6. So for number 6, you have the cube root of 16x to the 4th power times y minus 3x times the cube root of 2xy minus 5 times the cube root of 2xy to the 4th power. Okay, I want you guys to try that one on your own, so go ahead and pause the video when you're done with the problem, turn it back on, and we can check and see how you did. Okay, so let's take a look at this one. What we want to do here is we want to try to simplify each of the radical expressions. Okay, so when we look at that first radical expression, I want to break that up into the cube root of perfect cube factors times the cube root of our leftover stuff. Okay, so when we look at the coefficient 16, the largest perfect cube factor of 16 is 8. So our leftover numeric factor is going to be 2. The largest perfect cube factor of x to the fourth is x cubed, which leaves us with a leftover factor of x. And there is no perfect cube factor of y, so we're going to put that factor of y underneath the next radical. Okay, minus 3x. Now, there's nothing I can do to simplify the next radical. So that's just going to stay the cube root of 2xy, because there are no perfect cube factors of 2 or of x or of y. Okay, minus 5 times, we can take that last radical. The only perfect cube factor we have in that last radical is I can break y to the fourth power up into y cubed times y. And then our leftover factors there are 2x. Okay, so when we simplify this expression out front, the cube root of 8x cubed, the cube root of 8 is 2, the cube root of x cubed is x, times the cube root of 2xy, minus 3x times the cube root of 2xy, minus 5 times the cube root of y cubed is just y times the cube root of 2xy. And when we look at all three of those quantities, they have the cube root of 2xy in common. So if I factor that out, that leaves me with 2x minus 3x minus 5y. And then I can go ahead and simplify those two parts. Those are like terms, 2x minus 3x. That's negative x minus 5y times the cube root of 2xy. All right, and that is that expression simplified completely. Okay, we'll get into some additional examples in the next video.